The periodic table, section 9.1. Throughout this video, Carol Chemistry, I'm going to have you stop this every so often and fill out a couple things on the outline. So please listen for those things and write down that information. We'll collect that usually at the end of the chapter. Alright, here's just a quick overview of the objectives. Be able to explain periodic law, be able to tell me the differences between metals, nonmetals, metalloids, give me a rough sketch of the periodic table and tell me where those things are located, and talk about that stair-step line that separates metals from nonmetals. Those are kind of the main things that you should be looking for as we go through this. Alright, the periodic law, it basically states that if you put elements in order by their atomic number, you will see properties that reoccur periodically. And if you look at a lot of the physical properties, a lot of the chemical properties, you'll find out that the primary reason that they have those depends on electron configuration. So as you go through, and you know that if you look at everything in like group 1, they're always like NS1, and if you look at them in group 2, they're NS2, and so on. Those outer configuration electrons, these guys right there, those are the key. That's what gives it its properties. And so if you're grouped by those electron configurations, your properties are going to be similar. So Mendeleev, when he was doing it, did it by atomic weight, because at the time they didn't know atomic number, and then used chemical behaviors, and sometimes put those out of order if he needed to, but in general he still followed the atomic weight. Later on, a guy named Henry Moseley comes along, and he kind of figures out how to figure out the atomic numbers, the number of protons and so on. And so from that point on, we know that the atomic number is put in order by number, not mass. So here's the periodic table, and we're talking about metals, nonmetals, and metalloids. And I want you on your video to, or on your outline rather, to indicate where these things are located. So notice that all the red, those guys here, those are the metals. The blue, and notice that, in general the metals are on the left, except for hydrogen. Hydrogen, he's kind of the goofy guy. And these are the nonmetals, so those are the nonmetals there. And then these few right in the middle, those are the metalloids. So on your outline, stop this video, and I want you to write those down so that you know exactly where they are, because on the outline it's not a real good picture. Okay, remember, stop the video, write down where the metals, the nonmetals, the metalloids are. Alright, so let's talk about the metals. Most of the elements, if you looked at that chart, most of them are metals. They tend to be shiny, they tend to be dense, and usually have high melting points. They're also ductile, which means that you can pull them into wires when you're trying, you can roll them and pull them into wires. And they're malleable, which means that you can hammer them, pound them into sheets and so on. You can flatten them out and they don't break when you're doing that. They're also good conductors of heat and electricity. Most are solids, the exception is mercury. And they tend to lose electrons to form positive ions. And we'll talk about this a lot more in the next chapter, but they will, so you have a sodium and it's got one valence electron, and it's going to lose that electron and then become a positive ion. Some examples would be silver, gold, and zinc. Now, once again, would you stop the video and list 2 other examples of metals next to your outline, next to the slide of the metals. So list 2 other examples of metals. Okay, nonmetals are pretty much just the opposite. They're usually brittle, dull, and have low melting point. A lot of them are gases at room temperature even. They're poor conductors of heat and electricity, and they tend to gain electrons, and therefore they become negatively charged. When you gain an electron, the electrons are negative, you become negatively charged. Examples would be hydrogen, carbon, and nitrogen. Would you list two others on your sheet next to the slide for the nonmetals? List two other nonmetals. Metalloids have properties of both metals and nonmetals. And, they're kind of that transition between one and the other. So they could be either shiny or dull, depending on which ones you're looking at. And they conduct heat and electricity, but not as well as metals. A lot of times they're called semiconductors, which, of course, we know that those are very important when it comes to things like computers and stuff. Sometimes they're called semi-metals instead of just semiconductors. And like I said, they're very valuable when it comes to the computer chip industry. And a couple of examples would be silicon and boron. Would you list one more example? Write that down. That is the end of section 1. Just kind of know basically the metals, nonmetals, metalloids, where they're at, a little bit about them.